Welcome. So this is another question that we are going to tackle under photogrammetry. So this is a question paper of 2019. So this is 2017 November series. So I saw a good question here on which we can tackle, and we can go ahead and see where we can put more emphasis and do some more work on it. So this is lecturer Gadgira Steven from Matili Technical. So welcome to my educational video. So let's go directly to this question. So this is the next series of 2017 November. So define the term photogrammetry, 2 marks. I think that is something easy you can do. Then state the difference between a map and a photograph, 6 marks. So I'll make sure to provide a link below of some short notes where you can find such definition and the differences between even maps and photographs. So this is just a simple calculation in which you can do. So here we have question C and question D. So let me start with question C. So a vertical photograph at a scale of 1 into 10,000 is to be taken of an area whose mean ground level is 400 meters above the mean sea level. So if the camera has a focal length of 152 millimeter, find the flying height above the mean sea level. So 3 marks. So no harm in trying such a simple question. So here we have been given the scale, and here we have been given something. So the area whose mean, so this is the area of the, so this is the flying area above datum. Remember that this is 400 meters. So they need us to calculate the height of the flying aircraft. So the flying height of the aircraft, I've done it simple, just like this. So photo scale is equals to focal length over the flying height minus the height of features above datum. So my representation of the scale, so 1 over 10,000 is equals to the focal length. This is the flying height where we are searching for. So minus the height of features above datum. So the height of features above datum was in meters. I have converted it into millimeters. So this is just a simple question in which you can do. So this is just a simple cross multiplication. Having done that, I'll get my flying height as 1120 meters. So this is just a simple question of 3 marks. So 3 marks can help you move a grader above. So this is just the simple way. Make sure to go and look at the other formulas for calculating the photo scale, and you work more example on it. So let's go to the next question, question 8D. So in a pair of overlapping photos, the main photo base is 99.85 millimeters, and the mean ground level is 80 meter above datum. Two nearby points are observed, and the following information in the table 5 is obtained. So here we have point R and S, the height above datum for R, then we have the parallax bar reading for R and for S. Then again we have been given additional information. So if the flying height is 3200 meters above datum and the focal length of the camera is 210 millimeter, find the height of S above datum. So the data here is what they are looking for, a total of 9 marks. So this question was a good question in which you can tackle, and we can learn something there. So let's go directly to the solution. So the airbase represented by the capital B can be found from the expression. So small b over f, this is the focal length, is equals to the airbase over the that is HM, where HM is the flying height with respect to the mean ground level. The small b is the mean photographic base. So by having simplified that, so we go directly to the formula to solve it in order for us to get the airbase. So here we have, so the mean photographic base 99.85. we had been given that on the question. So this is the mean photo base length here, that is given in the question, over the focal length. So this 210 given again here on our question is equals to the airbase capital B over the, so here we have the flying height with respect to the mean. So the flying height with respect to the mean, also that is in the question. So here we have our flying height as 3200 with respect to the mean that we have been given here. The mean ground level is 80 meters above datum. So we subtract that. So we subtract the flying height minus the mean ground level given to us there. So through cross multiplication, this question is done easily. So by the use of a calculator, you cross multiply. So on this side you'll have 210b, that is the airbase, is equals to this is 99.85 into 3200 minus 8, so over 210 over 210, and that's where we get our mean. So this is the airbase as 1483 meters. By calculating the airbase, we move to our next solution there. So now here we have this, the parallax. So we can correct that a little bit. So let us correct here. So this is the parallax at R. So parallax at R. So this is parallax at R given here on our equation. So that parallax at R will be used to calculate. So let's continue there. So the parallax at R is equals to F, this is the focal length, multiplied by the airbase B over H, the flying height, minus the height above datum given to us here. So the height above datum for R, so that is the representation that I've done here. So that will be equal to, so here this is the focal. So by changing everything, so here I am calculating the data that I'm going to be using in order for us to calculate the other answers that we were supposed to be having. So this is the focal length multiplied by the airbase that I had gotten in the previous. So this is my airbase, I had gotten it there. So by multiplying that, the airbase B, then subtract. So this is the flying height given to us here on the question. So here we have the flying height, then here we have our height above datum there. So this is just a simple representation. So by doing that, I'll have calculated the parallax at R. So my parallax at R will be 99.43 millimeter. So with the direct reading instrument, my parallax at S will be equal to my parallax at R plus the difference between these 2 points here. So the difference distance, so that the distance difference in the parallax bar reading, so the difference in these 2 points that we have there, so the difference in those two instruments will give me so that's with an assumption of a direct reading, stereometer. So stereometer, that is a device that we are using. So here we'll have that the parallax found at R here plus the difference between those two parallax bar readings, and my answer will be 11.63 millimeters. After getting that again, so my difference in the parallax readings obtained here is equal to my parallax at S into brackets, so into brackets the difference in our reading, so the difference in the heights between R and S over this is the flying height minus the height of our R that we were given here. So the height above datum for R, so that is represented by the small h there. So this is the formula that gives us the answer that we are supposed to be looking for. So the difference between those two, so the difference in height between R and S here, this is the missing data that we are supposed to be looking in order for us to answer our question here, because we have been asked to find the height of S above datum. So first of all, I'm going to calculate the difference in the heights, the two heights. So by substituting the values that we have here, so the values that we were subtracting, that will give me 2.22. so that is the dp here, and our parallax at S, we have already calculated it as 101.65, so is equals to this is the value that we are looking for, already directly translated here, over our flying height minus the height above the datum given to us at R here as 68. So by direct substitution, I have already done it, so you can do it slowly. Here we'll have the correct representation of our data. So this is the flying height minus the height of the datum they have found there, multiplied by our the difference. So the difference in this parallax, that is 2.22 over 101.6. so by multiplying that, our answer will be 68 meters. So 68 meters is the difference in heights between R and S. In order for us to find the mean, so this is the height of S above datum, we are going to add the difference. So the difference between these two is 68. I'll add the 68 that was already here, the height above datum, plus the difference between this height and the unknown height here at S, and that will give me the height of S above datum. That is what I have done there. So addition of those two, so this is the difference in the height. This was already there, the datum of R, so that will give me 136 meters above datum, and this is the correct representation and the correct data that we are looking for in our equation. So thank you for everything. That will be all for now.